Section 3.2. Yep. The graph of a function. Okay, the first thing we're going to talk about is the vertical line test. Those of you who have heard of the vertical line test before would know that it says, imagine vertical lines through a graph. If any line crosses more than one point of the graph, then it is not a function. Imagine vertical lines through a graph. If any line crosses more than one point of the graph, then it is not a function. Let's experiment here a little bit. This is an absolute value graph. If I imagine vertical lines going through this graph, it crosses one point there, and one point there, and one point there, and one point there, one point there, ever more than one point. Does it ever cross more than one point? Nope. So yes, this one is a function, because every x value has only one y value. But what if we have something like a circle or an ellipse? Over here it crosses 0 points. Does that count for anything? There it crosses 2 points. And 2. And 2. Yeah, you can stop. That one might only be 1 if I hit it the right spot. But the fact is, if any of those lines hit more than 1 point, then the answer is no. Because that would mean that for each of these x values, there's like 2 y values, right? Yes. Which cannot be a function. Do you guys remember that test? Okay, do you need me to go through any examples of doing the vertical line test, or are you good with that? Alright. Otherwise, today, the things you're going to be learning, our objectives are, first of all, the first objective we just learned about is to know whether a graph is a function or not by using the vertical line test, right? Okay, so the other things we need to be able to learn to do today are we need to be able to find the intercepts, domain, range, symmetry, and I'm trying to remember if any of the problems on today's assignment actually ask you where the graph is increasing or decreasing. I don't think so. So we'll go, so finding the intercepts, domain, range, and symmetry of a function. Okay, some of this stuff we've learned about before, so we're just kind of reviewing it. Although when we learned about it before, we were applying it to any equation, any graph. Now what are we applying it to? Functions. Just functions, and that's it. Okay? Alright. We kind of practiced some domain and range on our self-starter today, so do we need more of that?
No. I think we're
Good, okay. Let's do this problem. For f of x equals 2x over x minus 2, we're going to answer a bunch of questions. First one. Is not if, is the point 3, 6 on the graph? Does this sound familiar to stuff we've already done? It should. How do we figure out if that point is on the graph? They didn't give us the graph. Okay, so we go 2 times 3 over 3 minus 2, which is 6 over 1, and that equals 6. Guess what? We plugged the 3 in, and what did we get out? 6. So is that point on the graph? Yes, it is. For x equals negative 2, negative 2, what is f of x? What am I asking you to do?
plug in
So we're just finding f of negative 2, right? So 2 times negative 2 over negative 2 minus 2 is what? Negative 4 over negative 4? I think the answer is 1. What do you think? So when x equals negative 2, y equals 1, or the value of the function at negative 2 is 1. Ooh, now we're going to turn the question around. If f of x equals 3, what is x? Plug it in where? What does f of x mean? What is f of x replacing? Y. So what is this actually saying? If y equals 3, what is x? So where do we plug it in? We plug it in for the f of x, for the y value. And then we have to solve. How do we do that? So I would just kind of turn this into a fraction and cross multiply. Right? Does that work? When it's a single fraction like that, that is what's easiest for me. But I think Fernando was saying something else that would work.
Confused about where they go when I multiply.
Okay, so you prefer the other way of thinking you multiply everything through by the least common denominator? Is that preferable? So the common denominator would be x minus 2, so you multiply this by an x minus 2 and you multiply this by an x minus 2, but this one cancels out. So you're just left with 2x, whereas on this side you have to multiply the 3 by an x minus 2. When you cross multiply, it's just that stuff is multiplied together and that stuff is multiplied together, and the two sets of stuff are equal. And it doesn't matter which side which one goes on. It makes no difference at all. Okay, so 3x minus 6 equals 2x. So it looks to me like x equals 6. Does that sound right? Next question. Sorry, did you need that? Are we good? Sorry, I covered it up. I can show it to you in a minute. What is the domain of f? Now, some students read this and get confused. What is the domain of f? They think, well, isn't f y and isn't domain x? Well, yeah, it's just talking about for function f, what is the domain? What can the x value be? Okay? What can x be or not be? So, what is the issue on this one? Anything? There's a fraction. And we cannot have what? We cannot have 0 on the bottom of the fraction. So x minus 2 cannot be 0, which means what? So x cannot be 2 because if we plug in a 2, then 2 minus 2 is 0, and we can't divide by 0, so that's not possible. So is that the domain? Yeah. So instead of saying where domain is, sometimes it's easier to just say where the domain is not. Okay, last one. List any intercepts. They didn't actually give us a graph. How do we list intercepts without the graph? We worked on this last week, I think, finding intercepts. How do we find intercepts algebraically? Okay, 0 in for y, solve for x. 0 in for x, solve for y. Good. So 0 equals 2x over x minus 2. We cross multiply. We get 0 equals 2x, so x equals 0. Then we do y equals 2 times 0 over 0 minus 2, which gives us 0 over negative 2, which just means y equals 0. So I believe there's only one intercept, and it's both the x-intercept and the y-intercept at 0, 0. Right? Okay, let's look at one more problem. Instead of having an equation, we'll actually look at a graph. Okay. So, did any of you need to see all of that? Or are we good? Moving on?